Light seems simple. It illuminates, it reveals, it travels from things to us. We think we see reality because of it. But what if light does not just reveal reality? What if it defines what can be known at all? What if the way light behaves is already telling us that our picture of reality is incomplete? Not slightly wrong, structurally wrong. We grow up with a stable idea. Light is something that moves through space. It leaves a source, it travels, it arrives, like tiny particles, or like waves spreading through air. Either way, it feels continuous, predictable, external. We point a flashlight, and light goes there. No ambiguity. This intuition works. It builds cameras, optics, engineering. But it rests on a quiet assumption that light has a definite behavior independent of how we observe it. That it simply is what it is. Now consider something small. A beam of light passing through two narrow slits. If light were just particles, we would expect two bright regions on a screen, one behind each slit. Simple trajectories, simple outcomes. But that is not what appears. Instead, a pattern, bright and dark bands, interference, a structure that only waves produce. Light behaves like a wave, spreading, overlapping, interfering with itself. This is not interpretation, it is measured, repeatedly. But now reduce the intensity, send light one particle at a time, single photons, separated, discrete. You would expect individual impacts, tiny dots, no pattern. But over time, the same interference pattern builds up, as if each photon interferes with itself, as if it does not pass through one slit, but through both. Not as a metaphor, as a prediction confirmed in experiment. This is where intuition breaks. A single entity producing a pattern that requires multiple paths. So we try to resolve it. We ask, which slit did it actually go through? We place a detector, we measure, and something changes. The interference disappears. The pattern collapses. Now we get two bands, as if the photon chose a single path after all. The act of measuring alters the outcome, not because of disturbance in a classical sense, but because the conditions of the experiment define what can be observed. At this point, the old picture fails. Light is not simply a particle, not simply a wave. It does not possess a single classical identity. Instead, its behavior depends on how it is probed, not subjectively, but physically. The experimental setup is part of the phenomenon. This is not philosophical language. It is embedded in the predictive structure of quantum theory, and it forces a shift. We assumed that physical properties exist first, and measurement reveals them. But here, what can be said about light depends on the interaction. Not everything can be defined simultaneously. Path, interference, mutually exclusive descriptions, both experimentally valid, but not jointly accessible. This is not a limitation of instruments, it is a structural feature of reality. At small scales, light is described by a wave function, a mathematical object encoding possible outcomes. Not hidden properties, not unknown values waiting to be revealed, but structured probabilities. The equations predict distributions with extraordinary precision. What appears on the screen matches calculation, but what the wave function represents, that remains open to interpretation. Some describe it as a real physical wave, others as a tool for prediction. Different ontologies, same measurable results. This is unusual. Physics typically tells us what exists. Here, it tells us what can be predicted, but leaves open what is fundamentally there. And yet, one thing is clear: light does not behave like a predefined object moving through space with fixed attributes. It behaves like something whose properties are revealed through interaction. This is the first fracture. Light is not just something we see. It is something that constrains what seeing can mean. From this point, the question shifts. Not what is light made of, but what does light allow us to say about reality itself? Because light is not just another phenomenon. It is how we access the world. Every observation, microscopes, telescopes, cameras, depends on light, or more generally, on electromagnetic interaction. So, if light behaves this way, then the structure we uncovered is not isolated. It is foundational. Now consider detection. A photon arrives at a sensor. It is registered, a discrete event, a click. This discreteness is not optional. Energy comes in packets, quantized. This is experimentally established. Photoelectric effect, photon counting, light transfers energy in indivisible units. So we have two facts. Light produces interference patterns like a wave, and it transfers energy like a particle. Both are directly measured. Neither can be removed. The classical categories fail, not because they are vague, but because reality does not conform to them. So, quantum theory does something subtle. It does not try to force light into one picture. It provides a framework that predicts outcomes, using mathematical structure without requiring a single visual model. The wave function evolves smoothly, deterministically, according to the Schrödinger equation, but measurement outcomes are discrete, probabilistic. This dual structure, continuous evolution, discrete outcomes, is not an approximation. It is how the theory works, and it works extremely well. Now the tension deepens, because we want to ask, what is the photon doing between emission and detection? Where is it? Which path does it take? The theory does not answer in classical terms. It provides probabilities for outcomes, not trajectories. If we insist on a trajectory, we leave the domain of experimentally supported description. Some interpretations introduce hidden variables, others avoid that entirely, but all agree on the measurable structure. Predictions remain the same, so the shift is unavoidable. The idea that particles have well-defined paths independent of observation is not supported at the quantum level. Instead, what we can say is tied to interaction, to measurement, to the experimental context. This does not mean that reality depends on human awareness. Detectors work without observers. Atoms interact. Photons scatter. Measurement is physical, not psychological. It is the irreversible transfer of information into the environment. Once that happens, alternatives are no longer accessible, not because they disappear in a mystical sense, but because they become entangled with so many degrees of freedom that they cannot be recombined. This process is known as decoherence. It explains why classical behavior emerges, not by removing quantum effects, but by dispersing them. The interference is still there in principle, but spread across the environment, effectively inaccessible. So the world appears definite, stable, classical, but underneath, the structure remains quantum. Light reveals this directly because it sits at the boundary, easy to produce, easy to measure, yet fundamentally non-classical. And this leads to a second shift. We assumed that objects exist with properties and interactions reveal them. But here, properties themselves are defined through interaction, not preloaded, not fully independent. This does not mean anything can happen. The structure is precise, highly constrained, mathematically rigid, but it is relational. What can be said about a system depends on how it is connected to other systems. Light, as the mediator of interaction, is not just carrying information, it is participating in the definition of physical reality. So when we see something, we are not passively receiving a pre-existing picture. We are part of an interaction that selects which aspects become definite. This is not subjective, it is physical, but it breaks a deep intuition. Reality is not simply there with all properties fixed, at least not in the way we imagine. Now step back. Light travels at a constant speed, in vacuum, always the same, independent of the motion of the source, independent of the observer. This is not a detail, it is a cornerstone of relativity. From this single fact, space and time themselves must adjust. Lengths contract, time dilates, simultaneity dissolves. Events that are now for one observer are not now for another. This is experimentally confirmed. Particle lifetimes, GPS systems, precision measurements. So light does something else. It defines the structure of space-time. Not just what we see, but how events are ordered, how causality is maintained. Signals cannot propagate faster than light. This sets a limit. Not technological, structural. Information itself is constrained. So light is not just a phenomenon, it is a boundary condition on reality. What can influence what? What can be known? What can be connected? And now, combine the pieces. At small scales, light does not have a fixed classical identity. At large scales, its speed defines space-time structure. In interactions, it mediates what becomes definite. This is not a collection of separate facts, it is a coherent pattern, and it points towards something deeper. We started with the idea that light reveals reality, but now, it seems that reality, as we can access it, is shaped by the behavior of light itself. Not arbitrarily, but structurally. The constraints of interaction define the limits of description. So the shift becomes clear. Reality is not a static collection of objects with intrinsic properties fully defined at all times. Instead, it is a structure in which certain properties become definite through interaction. Light is one of the primary carriers of that interaction. This does not make reality unreal. It makes it relational, stable at large scales, precise in prediction, but not built from independently defined pieces in the classical sense. And this leads to a final tension. We trust what we see, but seeing depends on light, and light does not behave the way we intuitively expect. So our most direct access to reality is already filtered through a structure that defies classical description. Not distorted, but deeper, more constrained, more subtle. So the question is no longer, what is light? But what kind of reality requires light to behave this way? And what does that say about everything else we think we understand?